dear student and my MSc student. Today I present thesis presentation entitled Metal Complexes of Metal Complexes of an Electrocyclic Complexes Synthesis X-ray Investigation.
चालू करो ये बैठ के ही दे दो ना नहीं वैसे ना कोई सकते हो तो कोई माइक तुम्हारा हमें कर दो चालू छे नहीं आवाज नहीं आ नीचे कनेक्शन वो फिट कर
X-ray investigation.
चालू करो बंद करके बता चालू नहीं
X-ray crystallography investigation, surface studies, DFT studies, and biological activities. Root made of my thesis was, first of all, I find that selection pathway of the drug designing. After selection pathway of the drug designing, I select the drug based on that activities as well as the half-life time. And after selection of the drug, I select the metal complexes to enhance the activity of the drug. And after selection of the metal as well as the drugs, I go for the metal complexes synthesis. And after synthesis of the metal complexes, I go for the confirmation of the metal binding site. And if metal is there in the binding site, then I go for the crystallographic analysis, single crystal growth. Why we need to single crystal growth? Because finding the structure function relation as well as the importance of the crystallography is that is give the intra and intermolecular interaction, and that is important in the drug designing. After if the single crystal is purely grown, then we go for the Murphy surface analysis. Why we need to do the Murphy surface analysis? Because find the active surface on the molecule as well as the percentage contribution of the interaction, and at the similar time also carry out the energy framework analysis. Energy framework analysis carried out because of finding the strength of the interaction, because in the crystal structure there is a lot of interaction is there, CHO and NSO is there. So which interaction is highly strong in nature, that confirmed by the energy framework analysis. And after energy framework analysis, we go for the lipophilicity and porosity analysis. And from the lipophilicity analysis is carried out to find the solubility of the compound in the polar solvent, and porosity is calculated because of finding the void on the crystal. And after also carry out the DFT study. DFT study is properly based on the theoretical analysis. And why we need to do? Because I select the pathway. First I synthesis, then theoretical analysis. Then if the complex are give the good response in the theoretical analysis, then we go for the experimental biological analysis, right? Because sometimes what happening if the metal complex is not give the good response in the theoretical analysis, so we cannot go for the experiment because it's a waste of time and a waste of the manpower. So if some compound maybe the compound is give the good DFT study, then we go for the biological activity. And from the biological activity, particularly we do the DNA interaction study, viscosity, cytotoxicity, and MIC study, and theoretical DNA interaction study using the docking score. Organization chapter. First chapter is the introduction, second is the synthesis, third is the copper complex of sulfur dimethyl, second one is the nickel complex of sulfur pyridine, fourth one is fifth one is the silver complex of sulfur pyridine, sixth one is the silver complex of sulfur diazine, and seventh one is silver complex of sulfur methylsulfur, and eighth one is the silver complex of sulfur chloropyridazine in presence of the second ligand pyridine and hydrate, and last one is the conclusion. Now chapter 1, the novel of the drug designing. The drug designing divided in two parts, one called the random scanning, and second one is rational drug design. Now in the random scanning, we first synthesize the complex in the laboratory level and go for the clinic trial, and if it shows the good response in the clinic trial, then we go for the phase 1 and phase 2 analysis. And if that synthesis complex is not give the good response toward the biomolecule, then we modify the drug and then re-analysis of the biological activity. So this is the random scanning. The rational drug designing is computational based drug designing. In that there is a divided in three parts. First one is a structure based drug designing, ligand based designing, and de novo and library based drug designing. And among the four, I select that ligand based drug designing. First I synthesize the ligand and I find the target using the PDB file, binding with that one, and if it shows a good response, then go for the experimental analysis. X-ray crystallography, the novel pathway in the medicine chemistry. In the structure based drug designing and rational based drug designing, we need the 3D structure, because if we don't have the 3D structure, then we cannot able to interact with the biomolecule, because whenever we study the interaction study, we need the crystallography, because the crystallography is the only technique that give the intra and intermolecular interaction. Also, this is one of the best technique that gives the pi and CH pi interaction, because whenever we discuss about the DNA, we need to analyze the pi and CH pi interaction. So select the sulfonamide. Why I select the sulfonamide? Because it's the oldest drug, as well as the antibiotic, anti-cancer activity, and also using the anti-HIV as well. But most of the sulfonamide are used as an antibiotic. So how it works? So in the bacteria and human being are not synthesized the folic acid. That folic acid is taken from the food. But in case of the bacteria is growth its own folic acid. And how it's going? How is growth of folic acid? Whenever the stearidine and glutamic acid is bound with the para-aminobenzoic, that called the PABA, and if that both the molecule are interact and the reaction with the para-aminobenzoic acid is synthesis the folic acid in case of the bacteria. But what happens when you take the sulfonamide as a drug? What happens in the sulfonamide NH2 moiety is bind with the stearidine and glutamic acid and it stops the synthesis of the folic acid. So it means that if you take the sulfonamide, then is what is the role of sulfonamide? Is just to stop the synthesis of folic acid. So it means that it stops the food of the bacteria, right? So sulfonamide is not to kill the bacteria, but it stops the growth of the bacteria. But why we need to improve the sulfonamide? Because sulfonamide are divided into three parts. One called the short-acting sulfonamide, medium-acting sulfonamide, and long-acting sulfonamide. Now, what is the acting? Acting means that effectivity of the drug. Okay, if you take the drug after 10 hours is acting, that's called the half-life time, right? So, in the case of the short-acting, the activity is 10 hours. In the medium-acting is more than 10, between the 10 to 20 hours, and in the long-acting is more than 24 hours. So, this is the disadvantage of the sulfonamide. Okay, so what is my target? I select the few sulfonamide drugs, sulfachloropidazine, sulfapidine, sulfamethoxazole, sulfadiazine, and sulfadimethoxine, and all are belong to the short-acting, long-acting, and medium-acting sulfonamide. Now, my goal is to modify the drug. This is a diagram of that drug, schematic diagram, 3D structure of that drug. So, whenever Patel is bind with the drug, it's enhance the activity and reduce the short life time. So, among the all, I select the silver, copper, and nickel as my metal. Why I select this? Because the literature survey show that in presence of nickel, copper, and cobalt, nickel, copper, cobalt, and silver, that bind with the sulfonamide, that enhance the activity of the sulfonamide drug. So that's why I select the silver, copper, and nickel. Silver, we know that silver is used as an antibiotic, copper used as an anti-cancer agent, and nickel used as a bone and the blood disease. The importance of the second ligand, whenever we grow this crystal, we need to dissolve in some solvent. So I select the three solvent, 3-methylpyridine, tetrahydropyrrole, and pyridine. Why I need to select this one? Because most of the metal complexes are dissolving this solvent. Because the metal complexes are not dissolving the water, DMSO. Sorry, some metal are not dissolving the DMSO, but methanol, ethanol. Okay. Chapter 2. In chapter 2, first I explain the technique. First I synthesize the metal complexes and go for the spectral characterization. And from the spectral characterization, if the metal is there, then we go for the single crystallization, that is crystallization. And after, if the 3D structure is coming, then we go for the DFT analysis and